Hi guys, I'm Minoora. I'm a second year engineering student in electronics and computer systems at Swinburne University, Australia. And I made this video for my object-oriented programming unit to summarize and show my understanding of the main OOP concepts. So OOP is a program design approach that had helped programmers to build complex programs in a simple way. As you can see here, there are four main concepts for OOP: abstraction, encapsulation, inheritance, and polymorphism. Let's have a look at what they actually mean in simple words. Abstraction is when we create an object to play its role as a real-world object. But what we mean by abstraction is that we only use what's relevant to our application. So in abstraction of our tree here, it may be a game, would be to provide the player with fruits or whatever, but we do not care about it growing or shedding leaves, which a real tree would. Encapsulation. Our lecturer always told us to consider an object literally like a capsule, but a smart one. It would know things and it would do things. We could ask an object for information or to do something for us, but we do not care what goes on inside. I would explain this in more detail when we talk about classes. Inheritance. Yes, as the name suggests, inheritance is inheritance. This is when the child classes inherit features from the parents. As you can see here, we have the Trump family. There's Donald Trump and his wife Melania and two of his kids, Tiffany and Trump Jr. As you see, they've inherited features such as hair color and skin color from their parents. This is exactly how our objects use inheritance. And this is well demonstrated in the shape drawing program, where the rectangle, circle, and triangle classes inherit features from the shape parent class. Polymorphism. As Andrew, our lecturer, always says, poly means many, morphs means forms. Let's look at Tiffany and Trump Jr. again. They both know how to play music, which is presumably inherited from their parents. Tiffany loves to play the piano, and she's pretty good at it. But on the other hand, Trump Jr. loves hitting stuff with sticks. Nope, not the Mexicans, guys, but he loves playing drums. As you can see, they both do the same task in different ways or forms. And in our shape drawing program, this is how the draw method works. Each child class of shapes would draw a different shape onto the screen. Well, that's basically the four concepts that make up OOP. Now let's have a look at how this can actually be used in a program. As we discussed before, an object in our program is an abstraction of a real-world thing which is encapsulated with its roles and responsibilities that we want to use in our program. But how do we actually create objects in programs? This is by making classes. A class is basically like the DNA behind any object. This is where we actually say what an object would know and do. And this is done by creating fields and methods. In a class, the fields could have different levels of exposure to the outside world. There are private fields where the information could only be used by the class itself and nothing else. Protected fields are a bit less private, but only the child classes could access this information. And finally, public, as implied, can be accessed by any object. So, when a child class knows things, this is the data stored in field or classes. They could be value type, which could be a number, like an integer or a double, or a string or whatever. But they could also know data from another object, or even use a whole object in the form of a reference, which points to that object or the data in it. A class would know how to do something by methods. A method is basically the set of instructions to do the task we want it to do. Every class definitely should have a method identified by its own class name. This is known as a constructor, which creates an object of the type of the class when called new followed by the class name. When we want an object to do something, we just call the relevant method of the object, and it would take care of it for us. Sometimes we might need to pass in parameters for the methods. This is known as overloading. Oh, there are the drums again. Okay, an abstract class is basically how you would create a parent class. An abstract class would contain at least one abstract method, and this is basically the skeleton of a method, just a declaration with parameters and no instructions. The parent class would expect the child class to override these methods and create the steps to do the task in their own way, which is how polymorphism works. And that's how a shape drawing program's classes override the draw method from the shape class to draw their own shape. But sometimes there could be virtual methods which do contain instructions, but this can be overridden by a child class to do the job the way it wants to. And also we might use interfaces in some programs, which is basically like a blank class with nothing but a bunch of abstract classes that are meant to be overridden. Alright, now that we have an idea how classes work, how will we get these objects to work in a program? Well, objects are really lazy and antisocial creatures. So this is why collaboration is important. We want objects to talk to each other and ask for information and tell other objects to do stuff. So one form of collaboration is dependency, and it is when an object would just ask for another object for info and tell it to do something. But this isn't an ongoing process, probably just a one-time thing. Association is when one object would have a reference or a pointer to another. So this is quite a stronger form of collaboration, because the objects would interact with each other quite frequently. And inheritance. This is the strongest form of collaboration, and you know why, because we've just discussed it before. Alright, so coupling is when objects are is very common when objects are inherited. This is because this basically allows objects to mess with another object's information, or they would use another object's methods. So just like the trumps here, both the kids would take the pocket money out of their parents' wallet and be fed by the parents, which is basically their parents' food, and even the damn Wi-Fi. So in coupling, we'd say an object would use the methods from another object and use these, and if these methods are changed in the previous object, it would not work in the objects which use those methods or whatever information. And cohesion is when objects interact with each other to get things done or ask for information. Just like Joanna and Daniel here.
Hey, what's the Wi-Fi password?
Crazy Monkey 12345.
Okay, thanks, bye.
In a similar way, the objects would talk to each other, get the other objects to do stuff for them, ask stuff from other objects. In here, they do not mess with the other objects' methods or information. Normally, a good program design would have high cohesion and less coupling. This means the objects would make other objects do most of the work for them and ask information from the other objects, rather than using and accessing the other object's data or methods. Alright guys, that's basically the key concepts and ideas behind OOP, and thanks for watching.